concentric spherical shells of radii 2 meter, 4 meter, 8 meter. These are spherical shells. They're like this. These are spherical shells. Yeah, they're all in this way. They're of radius 2 meter. The radius is in meters. The other is 4 meters. The other is 8 meters. Carry these spherical shells carry a charge density of charge density is in nanocoulomb per meter square. So charge density is 20 minus 4 and rho s. What is asking? What is the value of rho s? Here, what is the value of rho s that is required to ensure that the electric flux density is 0? The value of rho s for which d is 0 at radius 10 meter. If I consider one more shell now, of radius 10 meter, how much rho s should be kept here so that d will become 0? That's the question. Okay. Psi e is closed surface integral d dot ds as d is 0. Psi e as d is 0, psi e is 0. From Gauss law, we know psi e is equal to charge enclosed. If d is 0, psi e will be 0. So charge enclosed will be 0. Charge enclosed is charge enclosed by the innermost sphere Q1, middle and the third sphere Q3. Q1 plus Q2 plus Q3 is charge enclosed. The total charge enclosed is charge enclosed by this sphere and this, which is Q1 plus Q2 plus Q3, as D is 0, psi e is 0, Q enclosed is 0. Implies Q1 plus Q2 plus Q3 is 0. Q1, the relation between charge and charge density. Q is equal to surface integral of rho s ds. For surface 1, rho s1 ds1 plus s2 rho s2 ds2 s3 rho s3 ds3 is equal to 0. This is rho s1 into surface integral of ds1 is s1 plus rho s2 into S2 plus rho S3 into S3 is equal to 0. Rho S1 is 20 into 10 power minus 9. Surface 1 is having radius 2. Surface area of a sphere of radius r is 4 pi r square into 4 pi r is 2 square plus minus 4 into 10 power minus 9 into 4 pi, the radius 4 square plus rho s into 4 pi into 8 square is equal to 0. Is equal to 0. Taking the 4 pi common onto the RHS side. 2 square is 4. 4 into 20. 80 into 10 power minus 9. I am taking 4 pi onto RHS. Taking common and onto RHS. Minus 4 square is 16 into 4 minus 64 into 10 power minus 9 plus yeah, yes, or 16, yeah. 4 into 4, 16, yeah. This is 64, no? This is the first one. 4 into 20, 80. This is second one. Minus this 4 square is 16 into 4 is 64. Okay. Plus rho s into 64 is equal to 0. 16 into 10 power minus 9 plus rho s into 64 is equal to 0. Minus rho s into 64 is 16 into 10 power minus 9. Rho s is minus 16 by 64 into 10 power minus 9. Minus 0.25 nano coulomb per meter square. So answer is in nano coulomb per meter square. So answer is minus 0.25 nano coulomb per meter square. Is that clear? This is model 2. This is model 2. Any doubt? Yeah. Is that clear so far? Bhumika, Dinesh, Maniranjan, Kirtana. Satvik, Shalini, Tanushree, everyone. Is it clear? Good. This is model 2. So when you see a question, first you must identify the model. Okay. By seeing a question, you must be able to identify the model so that you'll understand the procedure next. Next question. Try to solve this. Yeah, try and solve this. Keep solving. Yeah, try and solve this question, everyone. Got the answer? Anyone got the answer? How to solve this? See here. This is one more model, model 3. Model 3. Sorry, lost the connection. Yeah, I'm sorry. Uh, there was a power failure. I'm sorry for that. I lost internet. Yeah. Is the is the screen shared now? We will see. Please confirm once. Yeah. Someone please confirm. Is the audio video clear? Screen shared? Yeah. Okay. Thank you. Yeah. Thank you. Two coaxial cylindrical sheets of charge are present in free space. One is having rho s, and rho s is 5 coulomb per meter square. At r is equal to 2 meter. At r is equal to 2 meter. The other having rho s, the other having rho s minus 2 coulomb per meter square, minus 2 coulomb per meter square. At r is equal to 4 meter. At r is equal to 4 meter. Find displacement current density D at r is equal to 3 meter. D at R is equal to 3 meter. D at R is equal to 3 meter. Okay. Yeah, perfect. This is R is equal to 3 meter. I want D at R is equal to 3 meter. Model 3 of Gauss law. According to Gauss law, psi E is equal to charge enclosed. Okay. Psi E is closed surface integral d dot ds is equal to charge enclosed. Surface integral of rho s ds. Now, there are three cylindrical sheets here. This is called the three model. What will do here? Now, this is the Gaussian surface. R is equal to 3 meter. Use your Gaussian surface. I need to find the charge enclosed by the Gaussian surface. So, Gaussian surface is enclosing this inner sphere, inner cylinder. So, when I do this calculation, I must consider okay. Okay. Yeah. Now, this is called a three cylinder model. When I am calculating the charge enclosed, I must calculate the charge enclosed by the Gaussian surface. This is the Gaussian surface. Charge enclosed by this Gaussian surface is the inner cylinder. Closed surface integral d dot ds is rho s of the inner cylinder into surface area of the cylinder. And here I will calculate the surface area of the Gaussian surface. Gaussian surface is rho is equal to 3 meter. So d into lateral surface area of the cylinder of radius rho is 2 pi rho L. This is 2 pi, rho is 3 into L is rho S charge enclosed by the Gaussian surface. Gaussian surface is enclosing the inner cylinder. So it is 5 coulomb per meter square into surface area 2 pi 2L. Radius is 2 meter for this. Therefore, this is no D is a long row. So I write D is D row. D row is 10 by 3. D is D row A row. 10 by 3 A row Coulomb per meter square. This is called a three cylinder model. The importance of this model is this inner cylinder, I can say the middle cylinder is a Gaussian surface always. And when I calculate charge enclosed, I must consider this inner cylinder. For Gaussian surface, I must consider this center cylinder. That variation you should understand. That's why this is very important. If you're doing it for the first time, if you don't know the concept, then you'll get very much confused by this. So, and you cannot do any guesswork and do this until unless you know the actual procedure. That's why it's very important, examination point of view. This is called a three cylinder model. Application of Gauss law, three cylinder model. Any doubts here? Everyone, is it clear? Maniranjan clear? Tanusri clear? Three cylinder model. Make a note of this. Three cylinder model. Next one. Try and solve this. The next question is two sphere model. Two sphere model. Try and solve this. Two sphere model. Two sphere model. This is your two sphere model. Try on. The two sphere model. Consider a uniform sphere of charge density rho naught. So rho naught is a volume charge density in this sphere. Inside this, like you fill air in a balloon or water in a balloon, it is filled everywhere. Okay. Consider a uniform sphere of charge density rho naught and radius b centered at the origin. It is centered at the origin, and this is having a radius b. The sphere is having a radius b. It is carrying volume charge density rho naught coulomb per meter cube. The electric field at radius r, electric field at radius r, at this radius, I have one more small sphere like this. Okay. And I want to find electric field at this radial distance r, where r is less than b, by using Gauss law. So again, Gauss law, psi e is equal to charge enclosed psi e is closed surface integral d dot ds volume integral of rho v dv. This is dr into the Gaussian surface is of radius r, dr into surface integral of ds, surface area covered by the Gaussian surface, which is sphere of radius r, dr into 4 pi r square. Rho v, volume charge density, is rho naught. Volume integral of dv is 4 by 3 pi r cube. Why? Because I want to calculate the charge enclosed by the Gaussian surface. Gaussian surface is of radius r. Now this rho naught is in this complete sphere. Now the amount of rho naught in this inner sphere is rho naught into the volume of this sphere. Therefore, in both the cases, I consider only r, not b. That's why this is again special. Unless you understand this concept, do it once. It's very difficult that you do it in the exam. So this is called the two sphere model. We always consider r, or always consider in calculation, we always consider radius of Gaussian surface only. We consider the radius of the Gaussian surface both in calculation of psi and q. So this is dr is rho naught r by 3. D is dr ar, rho naught r by 3 ar. D is epsilon naught r, or epsilon times of E. E is rho naught r by 3 epsilon ar. I want the magnitude. Magnitude is rho naught r by 3 epsilon. Rho naught r by 3 epsilon. Option A is the answer. And this model is also called as the two sphere model. Very important. Very important model. Any doubt? Dinesh, Kirtana, Maniranjan, Tanushree, any doubt? This is two sphere model. Different from this three cylinder model. This is the three cylinder model. This is three cylinder model. Here, when I am considering charge enclosed, I consider the inner cylinder. When I consider the flux cut by the Gaussian surface, then I consider the Gaussian cylinder. For charge enclosed, I consider the inner. For Gaussian surface, I consider the middle one. Whereas in the two sphere model, for both charge calculation as well as the flux, we consider only the Gaussian surface. That's why it's very, very critical and important to understand the variations of this. Yeah. Any doubts? Please respond in the chat box. Chatrik, Bhumika, Joy. Clear? Okay. Tanushree, clear? Any doubt in these two models? Am I audible? No one is responding. What happened? Hmm? Clear? Very good. Is there any lag in what I'm talking and what you are able to hear? Response is very, very slow. Okay, next question. After a two cylinder model and after a three cylinder model and a two sphere model, this is a standard uh, kind of a question. This is again model 1. In model 1, they'll give you D, ask you to find Q or psi E. In previous question, they asked to find Q. In this question, they are asking to find psi E. But it is same model 1. Solve this. Everyone solve it. Got the answer? Anyone got the answer? How to solve this? Model 1. Hmm? Anyone got the answer? Dinesh, Tanushree, Satvik, are you trying? Shall I solve or are you trying? Hmm? If you want me to solve, type at least solve. If you are trying, type trying so that I'll understand. Please type in the chat box. If you're trying, type trying. If you want me to solve, type solve. Yeah? Trying. Very good. Trying, 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 trying. Oh, oh, oh. Nice. Trying. Okay. I'll wait. I'll wait. Okay. I'll wait. Any answer? Yeah. What is given? Let A row A phi AZ be unit vectors along row phi and Z respectively. So cylindrical coordinate system. Cylindrical coordinate system. Given D is 15 arrow plus 2 row A phi minus 3 row Z AZ coulomb per meter square. The total electric flux in coulombs emanating from the volume enclosed by a solid cylinder of radius 3 meter and height 5 meter oriented along Z axis with its base at origin the cylinder is having its base at origin it is along Z axis. Height is 5 meter. Radius is 3 meter. This is the given data. It's asking us to find psi e. We know psi e is closed surface integral d dot ds. So if you evaluate this, you'll get the answer. But closed surface integral d dot ds is volume integral del dot d dv. Del dot d in cylindrical coordinates, as we done in the previous question, 1 by h1, h2, h3. h1 is 1, h2 is rho, h3 is 1, 1 by h1, h2, h3, 1 by rho. Shall I write the formula otherwise? If you want, I'll write the formula, general formula. Then I'll substitute if you want. 1 by h1, h2, h3, dou by dou u, h2, h3, arrow, dou by dou v, instead of that I write au, okay? Au. Av, dou by dou w, h1, h2, aw. Now substituting. Del dot d is 1 by rho, dou by dou rho, rho times arrow is 15, remember. Plus dou by dou phi, a phi is 2 rho plus dou by dou z, rho times minus 3 rho z. Please do not forget this minus. If you forget the minus, it will be a disaster. Del dot d is 1 by rho times 15. Dou by dou rho of rho is 1 plus dou by dou phi of 2 rho is 0 minus 3 row square. This is 15 1 by row of 15 minus 3 row square. Substituting psi e volume integral of del dot d dv. No, dv is should multiply the length along row phi z. Differential length along row is d rho. Differential length along phi is rho d phi. Differential length along z is dz. So volume is rho d phi dz. Rho d phi dz. This rho goes off. Psi e is triple integral 15 minus 3 rho square. D phi dz. This triple integral 15 d phi dz minus 3 times triple integral rho square d phi dz. This is 15 integral of 1 d rho limit 0 to 3 integral 1 d phi 0 to 2 pi integral of 1 dz z limit 0 to phi minus 3 times rho cube by 3 0 to 3 2 pi z 0 to phi. This is 15 into 3 into 2 pi into 5 minus this goes of 27 into 2 pi into 5. This is 450 pi minus 270 pi. This should be 180 pi. Is this clear? Yeah. That's how we solve this. Okay. One more similar one. You must be able to do this now. This is easy. You can do it. Everyone try and do this. Bhumika, try. Dinesh, Satvik, Mani Ranjan. Sorry, yaar, Mani Rajan. It is okay. Sorry, Mani Rajan. Okay. Yeah, everyone try. What is the answer? Did you people got the answer? Same model, no? What is there here? The static electric field inside the electric medium. Call it as a new model, model 4. Epsilon r given 2.25. E is given, expressed in cylindrical coordinates. 2 rho a rho plus 3 by t a5 plus 6 az. If the above expression represents a valid electrostatic field inside the medium, then the volume charge density associated with the field is asking us to find rho v. Okay. Apply Gauss law. According to the point form of Gauss law, del dot d is equal to rho v. So he is asking us to find the rho v. Rho v is equal to del dot d. Okay. So I want rho v. I should find del dot d. But you know, del dot d is del dot epsilon e. This is epsilon times del dot e. So if I find del dot e, substitute here, I'll get rho v, which is the ultimate thing I should do. So find now, again, this question boils down to del dot e itself. Del dot e, cylindrical coordinate, general form 1 by h1, h2, h3 dou by dou u, H2 H3 AU, dou by dou v, H1 H3 AV, dou by dou w, H1 H2 AW. This is 1 by, H1 is 1, H2 is rho, H3 is 1, scaling factors, 1 by rho of dou by dou rho of rho times A rho is 2 rho plus dou by dou phi, H1 is 1, H3 is 1, A phi is 3 by T plus dou by dou Z, H1 is 1, H2 is rho, AZ is 6, 1 by rho of, sorry, 1 by rho of dou by dou rho of 2 rho square plus there is no phi term 0, there is no Z term 0. So 1 by rho of 4 rho. This is 4. Del dot E is 4. Substituting here, rho V is 4 epsilon. This is 4 epsilon naught into epsilon R. 4 into 2.25 times epsilon naught. That is 9 epsilon naught. Option D is the answer. 9 epsilon naught. Option D is the answer. This is same problem until you understand this initial concept and reach up to this point. Then it is the same model. Okay. Is that clear? No? Any doubts here? Everyone, is it clear? Dinesh? Satvik, Bhumika? Next question. Okay. This is Morai. Try and solve this. This is based on Gauss law in true form. According to Gauss law in true form, psi E is equal to charge enclosed. Use that concept and try to solve this. Anyone got the answer? Please type your answer in the chat box. Anyone got the answer? Are the people trying or shall I explain? Shall I explain or will you people try? Shall I solve then? It's actually pretty easy thing to solve. What is saying? What net electric flux passes through a sphere of radius 2.5 meter? If I take a sphere of radius 2.5 meter, this is a sphere of radius 2.5 meter. What is asking? What is the net electric flux passes through this sphere? Psi E. But we know psi E is nothing but charge enclosed. It is enough to find charge enclosed. So if you want to know how much flux is cut by this closed surface, it is enough that you find the charge enclosed by this surface. The charge is given by the expression 2 power minus x square nanocoulomb. This is the expression for the charge located inside the sphere. Now, when I take x is 0, okay, this is located on the x-axis. When I take x is 0, then charge is 2 power 0, 1 nanocoulomb at x is 0. Then at x is equal to plus 1, consider this to be the x-axis. Then and x is equal to plus 1, this at x is 0. Then x is equal to plus 1, if you calculate, q is 2 power minus 1 or 1 by 2, 0.5 nanocoulomb. At x is equal to minus 1, it is q is again 2 power minus 1, it's again 0.5 nanocoulomb. At x is plus 2, q is 2 power minus 4, that's 1 by 16. Q is 0.0625. X is minus 2 also. Q is 2 power minus 4, 0.0625. Now the important thing is x is equal to plus or minus 3 is outside 2.5 meter. This will not be enclosed by the sphere of radius 2.5 meter. That is the point you need to understand. That this point is outside this 2.5 meter range. So you should stop your calculation here. That's important. That's the most important thing, is understanding that you need to stop there, because I want to find the charge enclosed by the surface. Surface is having radius only of up to 2.5 meters. So above that you can neglect. Now when you add up this will become 2.125 nanocoulomb. Therefore, option A is the answer. We'll go for one more last question. And at 2:30, we'll start communication revision. Now, given here D is 4x cube ax plus 3xz ay plus x square y az nanocoulomb per meter square. Find the total charge enclosed by the surface defined by 0 less than or equal to x comma y comma z less than or equal to 1. It's asking us to find the charge enclosed. Psi E is equal to charge enclosed is surface integral of D dot ds. This is volume integral of del dot d dv. Del dot d is 12x square. This is plus 0. This is plus 0. 12x square. Del dot d is 12x square. Do the integration. 12x square dx dy dz. This is 12 x cube by 3 integral 1 dy y integral 1 dz z limit 0 to 1. This is 4 times x cube limit 0 to 1. That's 1 into 1 into 1. This is 4 nanocoulomb. Answer is 4 nanocoulomb. And also find the amount of electric flux passing through the closed surface. But you know, amount of electric flux is equal to charge enclosed, which is also equal to 4 nanocoulomb. Now the question is whether the flux is entering the surface or leaving the surface. You know, charge is positive. Charge is positive. Then the flux will leave the surface. If charge is negative, flux will enter the surface. But because we got positive charge, flux is leaving the surface. That's also very important and tricky question. Very common, very general, but that point should strike at that point. Okay. So this briefly concludes the revision session. We'll start at 2:30. We'll start EMFT. We have completed EMFT revision. We'll start communications revision at 2:30. Thank you.